So I thought I'd walk you through what I've discovered so far with the tubes. Let me turn the power supplies on. And the tubes should light, and hopefully you can read what's on the tubes. So what I've done is I've taken a number of the wires from the edge connector, those little pin headers we soldered on. I've jumpered them to the breadboard here, and I've got ground here and +5 here, and I can change the signals between ground and +5. You can see right now on the hours I've got 23 displayed, and it is a binary input. So if I take all of the hour inputs high, remember it's 5 bits, we get 31. So let me, I don't want to touch the board and shock myself. So that should get me 15, 14, etc. So it's just a binary input across those 5 bits that gets displayed across the 2 tubes as the hours. So that would be is it displaying 17? That doesn't make sense at the moment yet. Does that make sense? This is a little fiddly. That should get me, okay, oh yeah, I've got 1 bit. This should get me 0. And there's the 1 bit. See, this is a little fiddly to do. Second bit, the third bit should get us a 4. The fourth bit should get us an 8. And the fifth bit should get us a 16. And if I take 16 and add 1 to it, we'll get 17, etc. So we know the hours are just a binary input. So let me make a note here. And this is what we assumed. And I'm going to assume this is true on both sides. It would make sense that it would be. So for the minutes, I didn't actually solder wires on for the minutes, but what I can do here is use another lead, and I can ground the individual bits. So the minutes are currently showing 63. So if I remove 32 from that, I get 31. I've just taken bit 6 to ground. If I take bit 5 to ground, we get 47. Bit 4 to ground, 55. We've just taken 63 minus 8. 63 minus 4 is 59. 63 minus 4 is 61. And 63 minus 1 is 62. So we also know that these are a binary input. Now the seconds are a little bit interesting. I have the seconds, this tube here, wired up. The others are floating. If I take that ground lead again, I need to be careful here. And I ground this pin. You'll see the tens of seconds decrease by 1. And on the other side, if I can touch them, it should decrease by 2. Can't get a good connection. Or is that by 4? Again, I got to be careful here. There's high voltage on that board that could be really rude. Let me get another lead clipped in there. Give myself some more length. So that should decrease the tens of seconds by 2 and the tens of seconds by 4. So we also know the tens of seconds is a binary input. And what's happening here is with the pin floating, the input of the TTL device is pulled high. So that's why that ends up those are currently ones because they're floating, but I can ground them and pull them low. So this is also a binary input, as we kind of guessed. And this is a binary input. Now we get down to the seconds, and I have the 4 leads here connected to the seconds, which is that tube, and it's currently a 0. And I can, of course, make it a 1, make it an 8, make it a 4, make it a 2. 2 plus 1 is, of course, 3. 3 plus 4 is 7. And if I add 8 to that, I'll get 15, and that's an illegal value. And as I had guessed before, that gets us into that state where you'll see 2 digits light up at the same time. And there it is. The 7 and 9 are lit. Now just the 7's lit. And that's because the decoding logic in the 7441 just does random stuff when you've got values above 9 input to it. So that was expected. We had guessed that before as well. So we know that the seconds is again as a binary input. And if I get around to the seconds least significant digit, it's not lighting well, as you can see. But I should be able to remove 7 becomes 6. That must be an illegal value, or there's just something wrong. Let's see. I can't see well. So that's removing 1. This should remove 2. It's really fiddly to get in there. I'm going to bring the voltage up a little bit and get that 7 to light all the way. It's 200. So at about 225 again, it strikes both sides. That should subtract 1. That should subtract 2. But it looks to me like we've got multiple. That should subtract 4. So there's obviously something there I don't understand, or there's an issue with perhaps that jumper on the board causing interference. Because remember, there was that strap on the board for divide by 10, divide by 5. So this is still a question, although I'm sure it's going to be a binary input in some ways. So now we get to these control pins over here. And I've got those jumpered here as a set. And this is the 12 or 24 hour. And all it does is seem to dim the tubes. It probably shouldn't be plugged in. It might actually be an output. And I believe that would be the white one here. I'm just going to take those as an output. We have the pin labeled off. Bring the voltage back down to 200 volts. And what off seems to do is disable that 1/10 of a second. You can also see the LEDs are blinking there, but it seems to disable that 1/10 of a second. Whether that's correct or not, I don't know. And then we get to the pin that was labeled WWV. And if I pull it high, you'll see the time jump to 31 for the hours. And that's because on the back side of the board for the hour inputs, the pins are all floating, and so they're all 1, so there's a binary 30, or a decimal 31 there. And so what that WWV pin actually does is select which hour minute block are getting loaded, and with it low, I'm going to call it front hour second, the top of the board, and one is bottom hour, hour a minute I meant. So it actually makes sense. So it could display the current WWV time, which I believe is GMT time. Or it could be changed to display the local time, which I've got set at 16. The daylight pin doesn't seem to do anything. Again, it might be an output. And finally, we have that OI pin. And it doesn't seem to do anything as well. Again, I'm going to have to do some looking at traces on the board to determine if those are outputs. Although it seemed like one of these was doing something with the LEDs. But perhaps not. But that's definitely progress. So you can see by using the jumper board and just some jumper wires here that I can move between ground and +5. I can get the tubes to do various things. I'm at the moment not convinced the 7441 that drives this tube is working. I may end up replacing it potentially, but you know, it's definitely interesting. Why didn't that? That's interesting. I would have expected to have seen the hours change, so maybe hours are currently set to 16. I can't seem to affect them, so it may be one of these pins is an inhibit. Oh, come on. Actually, I'm tying those to +5. That's not what I meant to do. Am I looking at the wrong side of the board? I'm actually, I think, looking at the other side of the board. The WWV pin is this orange right here, I believe. And it actually needs to be grounded to display the front of the board. That's what I had wrong, why this wasn't changing things. Okay. That was just me being stupid. Anyhow, I know enough now that we could design a circuit to drive the board and actually have it display the time. It requires a fair number of I/O pins. You know, if we just did a clock that could only, that ignored the WWV time, we would potentially need 5, 11, 12, 13, 14, 15, 16, 17, 18 pins here simply to get time up onto the board, including the tenths of a second. If we wanted to be able to change between two time zones, we'd have to add 11 more pins. So, from the microcontroller, that requires a fair amount of I/O pins, or possibly an I/O expander or some latches. But it's quite doable. So, we have a pretty good idea here at a high level how the board works. Take that back up to, or back down to 0. You can see that there's blanking. There's lead 0 blanking on the hours as well, which is kind of cool. So again, there's logic on the card itself to do that. This will take me to 7. This will take me to 1500 hours. And of course the one will light up for 1500 hours, which is kind of nice. So there is, like I said, leading zero blanking. So it's pretty cool. It's a lot of progress in understanding this card and getting to the point where I can, at some point, drive it as a clock. I've got that framework from an earlier video working with the B5951 tubes, where I've got a GPS. I've got all the C code for the PIC processor that listens to the GPS, produces a time struct, drives the time. It's all interrupt driven in the background on the PIC, so you can do other stuff on it. And it would be easy to kind of pare that code down to drive something like this. Because that code also can display strings and things on the tube, and all that could be stripped out. With 18 I/O pins, might be able to do this with a PIC 18 series and a 40-pin dip. Potentially might have enough port pins exposed to be able to do this. Anyhow, I'll give that some thought, and that'll happen some point down the road in a later video. I think I will wrap this up for now, and we'll talk soon.